So to determine if two functions are inverses, you do a function composition, and in that composition, two functions are inverses of each other if the following is true. Sorry, I have an extra word here. If the following is true. So when the following is true, we have an inverse. So f of g of x equals g of f of x, and all of that has to equal x. So every time I do this composition, it has to come out to simplify to x. This has to simplify to x. Okay, so what you do here is you will notice that instead of x, I'm replacing that with g of x. So in our problem, if we did f of g of x replaced that x. So when I rewrite this, I'm just going to write it one time. This right here replaced this x. So if it replaces this x, it will replace this x. Okay, so once you plug something in, it takes the place of every single x. Okay, so this x was replaced, so this x has to be replaced. So now it's just a substitution problem. So g of x actually equals 1/4 x plus 5/4. So when we replace that to have 1/4 x plus 5/4 equals 4, and then we replace 1/4 x plus 5/4 for the g of x, and then we have minus 5. So as you should know with function composition, this part right here will not change. That just stays the same. This is the part that we will simplify. So it is 4 times the function. So I do 4 times 1/4, which would be x, and 4 times 5/4 would be 5. And then this minus 5 would drop down. Now, as you can see, what's going to happen over here is the 5's cross out. So f of 1/4 x plus 5/4 equals just a single x, which was what we wanted. Because if both of those equal x when I do them, then these two things are inverses. So essentially what this is, remember that I replaced this right here, here. So that is the g of x, just to make it look like the notation. That's what it would be. So f of g of x does indeed equal x. But I have to check this one because to be inverses, it all has to equal. So let's do the next one. So I want to do g of f of x and this on this side. So again, this x was replaced by f of x, so this x has to be replaced by f of x. Plus the 5/4. Okay, so f of x, again, this is a substitution. F of x is 4x minus 5. So I do 4x minus 5 in for the f of x. And this is 1/4 times 4x minus 5. And then plus the 5/4. So again, I just, f of x was here and here. I replaced it off of this into those positions. Okay, and now I continue on with just some simplification. So again, this side does not change. That's how you do function operations. 1/4 times 4x would just be an x, and 1/4 times -5 would be -5/4. And you can see that these are going to cancel to 0. And I would have g of 4x minus 5 equals just a single x. And again, just to show you the notation here, 4x minus 5 is equivalent to f of x. So I have just shown that g of f of x equals x as well. So this has to equal to x, this has to equal to x, and obviously if both of them equal x, they both equal each other. So the answer to this is yes, these two are inverses. So f of x equals 4x minus 5 and g of x, which equals 1/4 x plus 5/4, are inverses of each other. Okay. All right, let's try the next one. So this right here, again, we're going to do, let me change to green here. We're going to do f of, we're going to replace it with g of x. If I replace this x with g of x, I do the same with this one. And then it's a substitution problem. So g of x equals x plus 3 in this problem. So x plus 3, and then x plus 3. All right, and then we simplify. This side stays exactly the same. I distribute and get this. I simplify to get this. All right, again, x plus 3 is equivalent to g of x, so I have f of g of x in this problem equals 3x plus 8. Now, to be inverses of each other, both of these have to equal x. Since this one failed, this does not equal x, it equals 3x plus 8, then no, they are not inverses. Are not inverses. So when you get just a single x here, you can't just assume that the other one's going to be x. You have to try it. But when you get something that's not x, then you can stop because both of those have to equal x for it to be function, for them to be inverses. So here, when I got x here, that's great, but I have to check this one because it has to equal x as well.